Okay, let's look at the next problem. In that we want to complete a perfect square trinomial. So I'm not going to probably draw this as neatly as I did the last one. I have an x squared algebra tile right here that's representative of this. Oh, well, sorry, it's y squared, whatever, it doesn't matter. So I'm going to call it an x by an x. And before, when we had 6x, we put 3 of them over here and 3 of them over here to be the x tiles. So I've got to put 5 over here because there's 10 of them, because I've got to make this so that it's equal on each the right side and below. So these are called x tiles. They're 1 by x's. There's 5 of them over here, and there's 5 of them over here for a total of 10 of those. Again, these could be called y squareds and y tiles. But what I need to do is I need to come up with a number. I got to add a number right here to make this into a trinomial that would be factorable, where the two numbers that I would put right here, here and here, they have to add to be that 10, but they have to multiply to be something to put a bunch of 1 by 1s in here. If this is 5 units this way and 5 units this way, could you tell me how many 1 by 1s I would put in here if it's 5 by 5 by 5? How many of those would I have? 25, yeah. So the number that I would add here is the number 25, because then this could be factored into y plus 5 times y plus 5, because 5 times 5 is 25, and 5 plus 5 is 10. And or I could write this as y plus 5, that quantity squared. Okay, so how do I come up with this number, this 25? I had 5 here and 5 here. There was 10. So what could you do with that 10? Ultimately, to get the 25, we put, half of them here and half of them here. Think about that. Hit pause if you want, so you don't want to hear me say what the process is. But if we took the 10 and divided it by 2, we'd get the number 5. 5 of them over here and 5 of them over here. To get the 25, we took 5 by 5, or 5 squared, to get that 25. So we took the b value, which was the 10. We cut it in half, and we squared it to get this 25. And then, would you notice that the b divided by 2, which is the 10 divided by 2, is the 5 that goes in here as well? So let's just do another one before we move on to a minus sign and some fractions. So say you had an x squared plus a 12x. You would take the b value, which is 12, you divide it by 2, and you'd get 6. You take the 6 and square it. That would be 36. But when you go to factor this into a binomial squared, the 12 divided by 2 is the 6. That's what's going to go in there in terms of that binomial squared. Now, it gets impossible to draw after this. So now I've just got to follow my process. So I have to take the b value of a -5 and divide it by 2. Please leave it like that. And then I've got to square that. So a -5 times a -5 is a positive 25, and 2 times 2 is 4. So the number that I add here is 25 over 4. But it's really easy to break this into a binomial where you put an x in the front of each of these, because it's just this minus sign with a 5 over 2. It's the minus 5 over 2 in each of those. And then you have a binomial squared. We'll see how we use this in a minute, but the next one, you'll take the b value of a -1/3 and divide it by 2. Well, when you divide by 2, you multiply by 1/2, and that's equal to a -1 over 6. When you square that, 1 times 1 is 1, 6 times 6 is 36. So you're going to add 1 over 36, but that's going to factor into z minus 1/6 and z minus 1/6. Here's that b value divided by 2 is that minus 1/6. You know, solving quadratic equations by completing the square is challenging. It's very, very interesting though, and I'm going to share with you some history in all of this. So it is quite fun. Before we finish the segment, we're going to get one more problem done. So let's do this process again. So if you want to complete a square by adding a number here, also I want to say to you, it's somewhat unethical to be doing what I've been doing. You know, how can you take x squared plus 6x and just add a 9 to it? You can't. But we're learning how to complete this square. What we're going to do later is we're going to do it with an equation. We're going to add 9 to both sides. And that you're allowed to do. So again, take your b value, which is a negative 10, cut it in half. That's a negative 5. That's the number that's going to go right here. T minus 5, that quantity squared. But that negative 5 has to be squared to figure out the number that I add to this binomial to make it a trinomial that factors into t minus 5 times t minus 5. So we're still doing the same thing we were doing just above, but we're trying to figure out how to take that b value, cut it in half, then that's going to be the value that goes right here, square it, so 3 times 3 is 9, 2 times 2 is 4, and that's the number you'd add to this, so that the binomial that you would multiply times itself would be x plus 3 halves times x plus 3 halves. Again, check it out. You know, the 3 halves times 3 halves is a 9/4, and the 3 halves x and this 3 halves x is a total of 6 halves x, which is this 3x. So again, a minus 5 over 6, and you got to take half of it. So that's going to be a minus 5 over 12. That's why this minus sign right here, and 5 over 12. But a minus 5 over 12 squared is a positive, always a positive. Whenever you square this number, notice these are always positives. Negative 5 times a negative 5 is 25. 12 times 12 is 144. And the number that you added to this as a fraction is 25 over 144. Okay, let's just do a problem so you can see how this is going to come about. So you see the x squared plus 6x. We want to keep the constant 7 over on the right side. But we want to take this 6 right here, and we want to cut it in half and square it. Cut it in half, 3, and square it. So 3 squared is 9. So we're going to add 9 to both sides of the equal sign. Now this is ethical. Now this is okay to do. The right side will become a 16. Whatever you do, just get that down. This is now a perfect square trinomial. It factors into x plus 3 times x plus 3. Because the two numbers whose product is 9 are 3 and 3, and they add to be 6. But remember, when you took the 6 and divided it by 2, that 3 is the number that goes in here. So now you have x plus 3, that quantity squared, equals 16. And oh, finally, we're ready to take the square root of both sides because we have a perfect square trinomial. We have completed the square. The square root of that binomial squared is x plus 3. The square root of 16 is 4, but it's a positive and a minus 4. We subtract 3 from both sides. I like to put that negative 3 first and then add 4 to it. Negative 3 plus 4 is 1, and a negative 3 minus 4 is a negative 7. So again, x is a negative 3 plus 4, which is 1, and x is a negative 3 minus 4, which is a negative 7. I want to take the original problem with you, and you see the equals 7? It happens that this problem is factorable. So if I brought the 7 over to the left side, I'd have a minus 7. And when I factor this, the two numbers whose product is a negative 7 are a positive 7 and a minus 1. And by the zero product rule and factoring, when I set x plus 7 equal to 0, I get a solution of x is negative 7. And when I set x minus 1 equal to 0 and add 1 to both sides, I get a solution for x, which is 1. So again, we got a 1 and a negative 7. I could have done it by factoring as well. Completing the square is pretty cool, and it's pretty important in all people who study physics and engineering's lives, because we want to get to the quadratic formula and solve using that, because it is much easier.